Welcome back. Today we're going to talk about solving equations, well, actually inequalities that are systems. So we're going to start out by talking about systems of inequalities, what it would mean to be a solution to an equation. Then we're going to talk about graphing inequalities, and then we're going to move into graphing two or more inequalities on the same coordinate plane. As we begin here, there's a couple of fundamental things we need to understand. An equation is a set of, it's a set of points that make a line. Okay, so you've got an equation for a line, and all of these points satisfy. When we're dealing with inequality, we're actually dealing with part of the graph, right? So you've got a line, and then it's one side or the other. Excuse me. It's going to satisfy that inequality. And so we have to understand what is a solution to an equation. A solution to an equation would be something that satisfies it or makes it true. So it's going to be a point an xy pair or a point that makes it true. Okay, so we're going to have to understand what it means to make it true. So it satisfies it. And when we're talking about inequalities, we need to look at what both satisfies the inequality and makes it and dissatisfies it or doesn't satisfy it. The solution to equations are on the line. And so when we're talking about an equation, we've got an equation for a line here. All of the solutions are on that line. Boom, 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 an infinite number of points. For inequalities, it's going to be in a region defined by equations. And I'm actually going to put equation and then S in parentheses because sometimes it's one equation, sometimes it's going to be a set of equations, maybe three or two, or just the one. So we're kind of in that mindset. So what ordered pair is the solution of the inequality y is less than 2x plus 3? So I always like to try 0, 0. So I'm going to say 0 is less than 2 times 0 plus 3, and that is true. So 0, 0 is a satisfactory solution to that inequality. Okay, so what might not work? Well, I don't know. So you could pick anything. The graph is going to help us pick strategically, but I always start with 0, 0 because that gives me kind of a baseline. Like it's very easy to calculate it in terms of multiplication, and so that's going to help us. All right, so let's review graphing a line. When we graph a line, we've got, this is our slope, and this is our y-intercept. And we're going to use our y-intercept first and our slope second. So our y-intercept is plus 3, so we go 1, 2, 3. And this is 0x 3y. Then we're going to use our slope. So our slope is 2 over 1. So I'm going to go up 2 over 1, up 2 over 1. And I'm able to connect my dots like this. Okay. So what would happen? Well, now, if this was an inequality, I'd test in a region. So I'd test something over here, or I'd test something down here, and whichever satisfies, that's the side that's shaded. Graphing a line is just the first step in solving these inequalities. Graph the parabola, y equals x squared minus 3. Well, the vertex is going to be, so this kind of tells me that it's a normal, so here's a quote, a normal parabola, right? And a normal parabola goes through 1, 1, and then 2, 4, 1, 1, and then 2, 4. So a normal parabola just goes through those, satisfactions, so 0, 0, 1, 1, because 1 squared is 1, and then 2 squared would be 4, and then 3 squared would be 9. So it's got to go through these points. This tells me it goes down 3, so down 1, 2, 3. So here's my new vertex. So my vertex is at 0, comma, negative 3, as given by my transformations. That's from chapter 1, so that's been a while, so just kind of review that in your head. And so I need additional points. So x equals 1, that would mean that y would be equal to, and I don't know, so I'm going to do this math. So 1 squared minus 3 would be equal to negative 2. So 1 comma negative 2 is my point on this side. So 1 and then negative 2. If x equals negative 1, so I'm going to go on either side of the vertex to give myself a, and now you can just sketch it, but that's not really all that precise. And so if I do x equals negative 1, so it'd be negative 1 squared minus 2 would be, sorry, minus 3 would be minus 2. So my next point is 1, negative 2. So negative 1, negative 2. So it's going to go up like this. And that's not surprising. It's that parabola that we had moved down. Again, if this was an inequality, we would test a point. So I would want to test the 0, 0 point inside the bowl, right? Because really this parabola extends up like this into infinity. So we really have two regions, inside the bowl and outside the bowl. 0, 0 is going to be in one of those places, maybe on the bowl. But we want to test a point and see which region we're going to shade. That brings me to graphing inequalities. To graph inequalities, first step is graph as if it's an equation. Y equals something, okay? And that would mean not less than, greater than, less than, equal to, greater than, equal to. So take out the inequality, put it in an equal sign, okay? And later we're going to put that back in. It's going to be solid line if equal to, and a dotted line if it's just less than or greater than. Second step is test a point. In each region. Shade the region if it satisfies the inequality. Okay, so after we get done graphing, we're going to define these regions, and we're going to test a point in each region to see if it satisfies it. So here we go. Draw the graph of y is greater than or equal to 2x plus 3. So that means that I'm going to graph y equals 2x plus 3. So I'm going to go up, so I'm going to use my y-intercept, 1, 2, 3, and then my slope is 2, so up 2 over 1, up 2 over 1. So my line is going to look like this. Okay, there's my line. And I'm going to test. I see that 0, 0 is not on the line, so 0, 0. So y is greater than or equal to 2x plus 3. So 0 is greater than 2 times 0 plus 3. Zero is greater than 3. So that is false. So that means don't shade the region with 0, 0. Okay, so if it's true, you shade that region. If it's false, you don't shade that region. So I'm not going to shade down here. So the way I can draw my graph is like this. So this is the part that's shaded up here. It's above that line. Okay? That's all there is to it. Now, it gets a little bit trickier, so they're going to switch this up a little bit. Obviously, in this next one, I have an equation that is not in a y equals form. So I need to solve for y equals. So let's start out with 2x plus 5. Y, and I'm going to set this equal to 7. So I'm going to come back to the fact that it's less than. And if it helps you, let's leave it like this because, you know, when we divide by a negative or multiply by a negative, we have to switch the sign. So let's leave it like that, unless you can keep track of it in your own mind, but it's easier kind of just to leave it up front. I'll subtract 2x. So I have 5y equals 7 minus 2x. Divide by 5, divide by 5. So I have y is equal to well, still less than or equal to. Less than or equal to negative 2/5 x plus 7/5. And so there's my equation here. So what does this mean? My y-intercept is 7/5. What is 7/5? Well, it's 1 and 2/5, so it's about there. And when I do this, I've got to go down 2 and over 5. So what does that mean? Well, I'm going to go to the same general space. So down 1, 2, over 1, 2, 3, 4, 5. So looks like this. So I have this region with 0, 0. So I'm going to test 0, 0. 0 less than or equal to, let's see, negative 2/5 times 0 plus 7/5. 0 is in fact less than 7/5. And so I'm going to shade this half of my graph right here. That's all there is to it. Solve it for an equation, graph that equation. Okay, so what I did was I left it as less than or equal to, but then I graphed it. So this is the line y equals negative 2/5 x plus 7/5, right? And when I graph that, I have the ability to shade these regions. Okay, that's really all there is to it. So let's talk about boundaries. The boundaries are the lines. The boundaries are the lines. And so if I've got a line that I made from an inequality, that's the boundary. So the line y equals ax plus b is the boundary for y is, and we could say less than, greater than, less than or equal to, greater than, equal to ax plus b. Okay, so the line is the boundary. And so y less than ax plus b is called a half plane. It's called a half plane because you basically take and split it, one half or the other. All right. So now we have to remember a little bit about Algebra 1 because we're dealing with our just x's or just y's. So an x equals 2 is going to be our boundary here. That's a vertical line. And the way that I remember this is, where's x equal to 2? Well, x equal to 2 here, it's also here, it's also here, 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 here. So all of these places are where x equals 2. So there's my boundary, and I want it to be greater than or equal to 2, so I know that it's solid. And if it's greater than 2, it's got to be on this side. Y equals 2 is the boundary. And y equals 2 is here, 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 here. All of these are y equals 2. And this one is less than, so it's going to remain dotted. And if it's less than that, it's going to be the part underneath. Okay, so a lot of this skill is really just remembering your algebra skills of graphing these lines. All right, we did this one. This was a normal parabola down 3. And so it's going to go through 1, 1, and then 2, 1, 2, 3, 4. It's going to look like this, right? Because it is a parabola that has moved down 3. This means it's solid. And I want what's greater than it. So you can conceptually think of what's greater than it, but we're going to test 0, 0. So 0 greater than 0 squared minus 3. So is 0 greater than or equal to negative 3? Yes, so in here is where I'm going to shade because 0, 0 satisfies this inequality. Same thing for this one, except it would be a dotted one. Now, systems, here we go. This is where it's going to get a little bit tricky. And so when we solve systems, the reason why it's tricky is because we have multiple regions. So we're going to graph both on the same graph all lines, and then test the regions. So I'm going to graph y equals x squared. I'm going to graph this. So this one I have to do a little bit of fixing on. Subtract 2x, 3y less than, not equal to. Let me erase that. 3y less than negative 2x plus 4 over 3. So my line is going to, my boundary, my line is going to be y equals, really y is less than, negative 2/3 x plus 4/3. So I need to do a little bit of graphing here. Let me graph my x squared first. So 0, 0, 1, 1, 2, 4. 0, 0, 1, 1, 2, 4. Here's my first one. There's my first one. Done. I'm going to graph this one in green. So plus 4/3 would be here. And then I'm going to go down 2. So down 1, 2 over 1, 2, 3. Down 2 over 1, 2, 3. All right, check this out. How many regions do I have? Well, I've got 1 here, 2 here, 3 here, 4 here. Whoa, it's a lot. So let's do this way. When you've got a system here, you test these regions. Well, kind of. When you're testing the regions, really you're trying to get an idea of where are both satisfied. Okay? So here's what we're going to do. We're actually going to test a region as if each of them is individual. So I'm going to test, let's just say, a good one would be 0, 2. Why isn't 0, 0 going? Well, because it's on the graph, right? So that's kind of tricky. And really, this should be, they should both be dotted, right? And so these are actually dotted. So both of my graphs should be dotted here. And I'm going to test 0, 2 because it's inside the bowl and it's above the line. And so I'm going to test 0, 2. So 2, is it greater than 0 squared? 2 is greater than 0 squared because 2 is greater than 0. And so I'm going to shade inside my parabola. So that's for y greater than x squared. For y is less than negative 2/3 x plus 4/3. I'm going to test 0, 2 as well. So we're going to test 0, 2. So that means, let's see, 2 is less than, because I've got 2 here, 2 for y, is less than negative 2/3 times 0 plus 4/3. Well, 2 is less than 0 plus 4/3 is false. So I'm going to shade the side opposite. And what we see is this. I need to see where it satisfies both. So that means the overlap. Here's the overlap right here. This is my solution where the overlap is. All right? That's my overlap. So my overlap is right there. That is the only part of, that's the only solution right there. It's just that little tiny sliver piece. All right? Go ahead and pause. Pause here, try this one. When we come back, I'm going to graph this one and I'm going to show you what exactly is going on here and what the solution is. All right, we're back. So let's graph these two. So I'm going to graph y equals 2x plus 3 and y equals x squared plus 2. So 2x plus 3, so I'm going to go to 3. I'm going to go up 2 over 1, up 2 over 1. Here's my first line. And my parabola is a parabola that is plus 2. So I got here. So I'm going to go 1, 1, 1, 1, 2, 4. So it looks like this. I need to see where this, where exactly is my overlap. So I'm going to test 0, 0 because it's outside of the defined region. So test 0, 0. So here's A and B. So test A is going to look like this. Y is less than or equal to 2x plus 3. So I'll put in 0. 0 is less than 2 times 0 plus 3. 0 is in fact less than 3. So on my line, I am going to shade this side. For B, that's my x squared plus 2. So y is greater than x squared plus 2. So 0 greater than or equal to 0 squared plus 2. 0 greater than 2. False. So that means I'm going to shade the side opposite. So 0, 0 is on the outside of the parabola. So I'm going to shade the inside of the parabola. So where's my overlap? Again, it's this sliver piece. It's not always going to be the sliver piece, but in this case, it's the sliver piece. Right there is the overlap. Okay, that's all there is to it. Okay, that is all there is to it. So, what else are we doing with this? We're going to continue to solve these systems. Here's one with 4. This one has 4 equations. It's going to be the same thing. So we're going to spend some time looking at the graphs of each individual line and where do they intersect. So for this one, y less than or equal to, and I'd subtract 2x, so minus 2x plus 10. For this one would be y is less than, I'd subtract 2x, so and then divide by 3, so I'd have minus 2/3 x plus 14 over 3. This one is x is greater than 0, equal to 0, so y is greater than or equal to 0. So what would it look like? So I got to graph my 4 lines here. Negative 2x plus 10. Let's make each of these 2, 2, 4, 6, 8, 10. And negative 2x plus 10 would be down 2 over 1. Down 2 over 1, so it looks like this. And again, I'm making these each worth 2. So then I've got minus 2/3 x plus 14/3. So 14/3 would be, so 14 divided by 3 would be 4 and 2/3. So here's 4 and about 2/3. So I'd go down 2 over 3, down 2 over 3. Kind of looks like this. Right? And if x is greater than 0, that's going to be my axis here and my axis here. So check it out. I've got this region, and I want to shade this. If it's less than negative 2x plus 10, I can test a point, and a point that's inside. So look at this. So I'm going to test, I can test 2, 2. And so for this one, is 2, so y, less than negative 2 times 2 plus 10. So is 2 less than or equal to negative 4 plus 10? So 2 is less than 6? Yes. So for my first one, I'm going to shade this side. And there's going to be a lot going on here. So it's less than that. And hopefully you start to see that less than kind of generally means underneath. And so you can kind of get an idea of where we're going here. Let's test the next one. So is 2 less than or equal to negative 2/3 x plus 14/3? And that's going to be 2 is less than, and this is going to be negative 4/3, because that would be negative 2 times 2, plus 14/3. So that would be, is 2 less than 10/3, because those would be 10/3. And so this is 2 is less than or equal to 3 1/3. That is true. And so we're going to shade the place underneath my blue line here. Right. And then I've got x is greater than 0, so it's going to be this piece here, because all of this is shaded, right? And then y is greater than 0 is going to leave me with just this region here that's shaded, right? Just that region defined by those lines where everything overlaps, okay? That's all there's to it, guys. And linear program just maximizes and minimums in systems. So I've got a huge system of equations here. And in a system like this for linear programming, my objective function in this example, so here's a huge system, and obviously they graphed 1, 2, 3, 4, 5, 6, 7 equations. So there's 7 equations there. My objective function would be like this. I've got all these constraints on the prices and things that cost me to make a cell phone. My objective function is how much money I'm making. So inside these constraints, how much money am I making on these phones? And so to find the maximum minimum, find the maximum and minimum values of the objective function. F of x, f equals 5x plus 8y, subject to the constraints. The maximum and minimum come at intersection points. Okay, so those are going to come at intersection points. And so we need to be able to find those intersection points. Excuse me. To find those intersection points, I'm going to encourage you to use your calculator. When you use your calculator, you can calculate your intersection points and then plug the intersections points into the objective function. And that's going to help you find the max and the minimum. All right, that's all there is to it. I'm gonna skip over that part in this video, but allow you to come in and ask questions about that. If you have them, we're going to do quite a bit with that in class today, and so that's going to give you a better idea of that when we get to that point. Okay, so thanks for watching, guys, and we'll see you next time.